Okay, so for calculus, I don't really want to do anything new today. I really would like today to be more of a day off for you. But what I am going to do, because I was asked to, is I'm going to go over a few answers from section 6.2, just a few of them, so that you can kind of, if you're going wrong somewhere, hopefully you can see where. And then someone pointed out that out of 6.3, number 8, the answers are not at the back of the book. It actually says see the ebook. So I will do number 8. I'll do those questions. Please try them yourself before you check the answer, but I will do those. So starting in section 6.2 on page 327, I was asked to do 2 A, C, E, and F, which is all of them. I don't think I'm going to do that. I think I will do 2. Let's say I do C and F. All right, so I'm going to do 2, C, and F. And then I was asked to do number 5. Hopefully, if I do that, if some of the other ones were questions, if you're getting most of them wrong, it's likely not just you screwed up a sign, it's probably there's something going wrong in your method. So let's see. Number 2C says, without graphing, find the absolute max and the absolute min of each function. So for 2C, it says 9 minus x squared. And you can say y is equal to f at x is equal to, doesn't matter. And they say x goes from -2 to 1. In other words, they're only graphing the portion of this graph where x is -2 all the way to 1. And they're not continuing that graph. So the first thing we need to do is we would need to figure out, I'm just looking for Harriet, there she is. We need to figure out if my x is -2, what's my y? And if my x is 1, what's my y? And so all I'm going to do is put -2 in here. So -2 squared is 4, and 9 take away 4 is 5. So it says without graphing, but just to give you a visual, what that means is the graph starts at -2 and 1, 2, 3, 4, 5. So let's say it starts there. And it ends when x is 1. So 1 squared is 1, 9 take away 1 is 8. So at 1, it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it ends there. Now, I don't know, does it go down this way? Does it go up this way? What's it doing? So I need to figure out, is there any local maximums or local minimums? They may or may not be absolutes, not sure yet. So I'm going to find the derivative, which is going to be -2x. I'm going to make it equal to 0, and I'm going to solve. So x would be 0. So now I'm going to make myself a little table at 0, and I'm going to pick a number before, I'm going to pick a number before 0, like -1. And if I put -1 in, -1 squared is 1, and 9 take away 1 is +8. So that means the graph is increasing. And then I'm going to try something after 0. I already know what 1 is, but let's try 0.5. 0.5 squared and 9 minus that is +8.75. So it's still increasing. So it doesn't look like there's a place where it changes direction. Although I would think there should be. -x, because 9, I would think it should reach its maximum. Anyway, Anyway, that's what I get, that it's increasing on both. So let me look at the back of the book and just see if they agree with me, because in my head that doesn't make sense, but I'm checking. 6.2, and I'm doing 2C, 2A, B, C. Yeah, that's what I thought. Absolute maximum should be at 9. So hold on. Remember, that is negative 2x, so 0. Okay. So I'm trying to figure out why, because it should be decreasing after 9. So, but it's not. Oh, because I'm stupid. Because your teacher's stupid. Welcome to your stupid teacher. I hope you were yelling at your screen because your teacher's dumb. Again, if we were in class, I'd be going, so what did I do wrong? And I get you to tell me, but you're not here. So let me tell you what I did wrong. I did wrong what everybody does wrong. And that is when I pick a number before 0, say -1, I don't put it back up into here. I'm supposed to put it into the derivative. Duh. So -2 times -1 is positive, which means it's increasing. Okay. But if I choose a number after, so I can even choose 1 if I want to. So as long as it's after 0, so if I choose 1 and I put it in here, -2 times 1 is -2, so it's down. So now it's decreasing. So I have a local maximum when x is 0. Now I don't know if it's an absolute maximum or minimum, so what I'm going to do is I'm going to figure out at 0 what is my y. Well, 9 take away 0 squared is 9. So it's like up here. So the graph is basically doing this. So what is my absolute max? This is 9 is the biggest number here, so that is the absolute max. What is the absolute minimum? Well, 5 is, because that's the lowest y value I have. So that's the absolute minimum. So maybe you're making the mistake that I did. Maybe when you're picking a number, you're putting it back up into here and not into your derivative. Check that. Could be your problem. Certainly was mine. All right. F. Let's see if I can do that one without questioning myself. Oh, that's a mess. Let's see if I can do that one. Let's see if this cloth works better. Oh, it does. Okay. That's better. You know me and messy whiteboards, I can't stand it. All right. So, what am I doing? I'm doing F. Says 2x squared minus x to the 4th. And again, they give you parameters that the x is going to be between 0 and 4. So the graph is going to begin when x is 0. It's going to end when x is 4. So I'm going to figure out what are those beginning points and what are those end points. So I need a y value. So I go back to the y equals. So if I put 0 in here, I get 0. And if I put 4 in here, I don't know what I get. Just hold on. If I put 4 in there, 4 squared is 16 times 2 is 32 minus 4 to the 4th. So I get negative 224. Very low value. Very low. All right. So now I need to figure out, are those in fact the absolute maximum, absolute mins, or does it go lower or higher at some particular point? So I'm going to do the derivative. So that would be 4x minus 4x cubed. So I would take 4x out as a common factor, which would leave me with 1 minus x squared, which would leave me with 4x times 1 plus x and 1 minus x, and I'd make that all equal 0. So either 4x equals 0, which means x is 0, or 1 plus x equals 0, which means x is negative 1, but according to this it can't be negative 1, so that's a no-go. Or 1 minus x is equal to 0, which means x is equal to 1. So those are my two test places. So I've got 0 and 1. I can't check anything before 0 because the graph starts at 0. So I can't check anything in here. So I can check something between 0 and 1. Unfortunately, that has to be a decimal or a fraction, so I'm going to pick 0.5. Put it back into your derivative. So, and it doesn't matter. You can put it back into this or into the factored one. It doesn't matter. So if I do 0.5, 4 times 0.5, that's 2. And then, let me see, 0.5 cubed times 4. So really this is 2 minus 0.5. I get a positive answer, which means it's increasing. After 1, I can pick any number after 1 as long as it doesn't go above 4. So I'll pick 2. And I'm going to put it back into my derivative. So 4 times 2 is 8 minus 2 cubed is 8 times 4 is 32. So I get a negative answer, which means it's decreasing. So I have at least a local maximum when x is 1. So I'm going to figure out then what is the y value. So again, if I need a y value, that's when I go back up to the original because y is this. So I'm going to put 1 in here. So this would be 2 minus 1, which would be 1. So out of those 3 points, the highest one is this. So that is the absolute maximum. The lowest one is this. So that is the absolute minimum. And that's how I'd go about that question. Number 5, I'm not going to use this because I saw what happened last time. Number 5, let's see what it asks. If I throw this in the washer with other clothes, is it going to turn my other clothes black? I don't know. I'll have to throw it in with dog beds, things I don't care about. All right, so number 5. It's a word problem. So it says the volume of a shed in the shape of a rectangular prism with a height of x meters, so all of that doesn't matter at all, is given by volume is 120x minus 46x squared plus 4x cubed. And they say that x, which remember is the height of my shed, could be anything from 0 to 4 meters. So we're not going to build a shed 0 meters tall. That would just be something flat. That would be dumb. There needs to be some height to it. And we're not going to make the shed any taller than 4 meters. You don't need a shed that tall. All right. So determine the height of the shed that has an absolute maximum volume. So we need an absolute maximum. That's all they're saying. What is the absolute maximum here? Okay. So I'm going to start this off. I'm going to figure out what is my volume if my x is 0. So I would put 0 into there. Turns out it's 0. What is my volume when my x is 4? Well, I don't know. I got to put that into there. So that would be 120 times 4 minus 46 times 16 plus 4 times 4 cubed. I get 0 again. Neither one of those is very, very good. 0 volume is not good. So I'm going to look for something in the middle. So I'm going to do the derivative. So that would be 120 minus, what would that be, 92x plus 12x squared. Oh, lovely. So I'm going to make that equal to 0. And so I have a trinomial. Now you could factor that trinomial, or you could do the quadratic equation in it, whichever you're comfortable with. I think everything there divides. No, 92 doesn't divide by 12. That's too bad. So it's up to you whether you want to try and factor it, or whether you want to try and do anything with that. Let me see, 92 divided by 4. Oh, I could take 4 out. 92, 8, no. I could take 4 out as a common factor. I could do that. 120 divided by 4 is 30, minus 92 divided by 4 is 23x plus 3x squared. That way, whether you're factoring or doing the quadratic equation, you're at least working with smaller numbers. So let's see, if I do 3x and x, and I do, let's say, 6 and 5, that would be 18 and 5, which would be 23. Hey, that works. And so that would be minus, and that would be minus. That would work. And so either 6 minus x would equal 0, or x would equal 6. And you could do this by quadratic equation and you get the same thing. Or 5 minus 3x is equal to 0. So 5 is equal to 3x. So unfortunately, x is 5 over 3, which would be like 1.66666 forever, right? So we automatically reject this answer of 6 because that's bigger than 4. So that's a no. So 1.6 is what I'm getting. So again, or 5 over 3. So I'm going to pick a number before 1.6, like 1. I'm going to put it back into the derivative, and I'm going to see whether I get a positive or a negative. So that would be 120 minus 92 plus 12. I don't know what the answer is, but I know it's positive. And so that means it's increasing. I'm going to pick a number after 1.6, like 2, and I'm going to put it back into the derivative. So this would be 120 minus 92 times 2 plus 12 times 4, which would be 48. I get a negative answer, which means it's decreasing. So I at least have a local maximum when my x is 5 over 3. Unfortunately, I need to figure out then what would the y value be. And so I need to put it back into this up here. So this is going to take a minute. 5 over 3 cubed times 4 minus 46 times, now 5 over 3 squared would be 25 over 9, and then plus 120 times 5 over 3. Whew, I get a yucky number. Whoops. I get a yucky number. I get 90 and 20 over 27, which is like 90.7. So I get that the maximum volume would be 90.7. Now, because that's a weird answer, I'm just going to double check. 6.2, number 5. It's hard to find the answers, eh? 5. Oh, there we go. 5 over 3 meters. Yep, that's what it is. So the maximum happens when the x value is 5 over 3. It didn't ask what was the maximum volume. It said determine the height of the shed. Well, when the height is 1.6 meters, the maximum volume of that shed is 90.7. So this is actually what they wanted as an answer. All right, so I hope that helped a little bit with that section. Now, someone said the answers were not in the back of the book for number 8 on the homework. That was, it's actually not due until Monday because I was giving you until Monday. I don't think it was due till Monday. I think I made it due Monday. Too many classes, no brains. But I'm gonna do number 8 so that when you want to check your answers, you can see if you're right. That's assuming I can do it right. So, number 8 was on page 339. And number 8, I got you to do A, C, and E. So the instructions said use the first and second derivative test to determine the maximum points, the minimum points, any points of inflection, and then it wants you to graph it. So that's why the answers are not at the back of the book, because it says to graph it. So 8a says x squared minus 4x plus 6. X squared minus 4x plus 6. Now there's no beginning or end to this graph, it's just the graph. So we need to talk about maximums, minimums, and points of inflection. So the first thing we're going to do is we're going to do the first derivative, which is going to be 2x minus 4. We're going to make it equal to 0, and we're going to solve, which would be 4 is 2x, so x is 4 divided by 2, which is 2. So there is a potential local max or local minimum at 2. 2 is a critical number. It is a place where the graph could switch directions. It doesn't necessarily, that's why I'm going to check. So I'm going to pick a number less than 2, and we have no restrictions because it doesn't say x starts here and ends here. So we have no restrictions on what we can pick. So I'm just going to pick 0, put it back into the derivative. So 2 times 0 is 0, minus 4 is negative 4, so the graph is going down before 2. After 2, so say 3. 2 times 3 is 6, 6 take away 4 is 2, that's a positive answer, so it's going up. So I have a local minimum when my x is 2. Now I'm going to figure out where do I need to put that on the graph. I need a y value. So I'm going to go back to the y equals thing. And I'm going to go 2 squared is 4. That would be 4 minus 8. So that would be negative 4 plus 6. So that would be positive 2. I think I did that right. Now I need to know whether there are places where it shifts from being concave one way to being concave another. So that is the second derivative. So the second derivative is just 2. If the second derivative is just 2, there's no way to make that equal to 0. So that means there are no points of inflection. And because it worked out to be a positive 2, that means this graph is always concave up. So when I go to graph this, it has a local minimum at 2 and 2. Before that it's going down, after that it's going up, and it's always concave up, which this appears to be. And it makes sense because this is a quadratic, it's an x squared, it should be a parabola, and it is. So everything makes sense, so I'm assuming I'm right. C. Eight C says x cubed plus x squared plus 6x. X cubed plus x squared plus 6x. That's my y. Again, no start and stop point, so it just continues forever. So the first thing we're going to think about then is, are there any local max or mins? So I'm going to do the derivative, which is going to be 3x squared plus 2x plus 6. So I'm going to make that equal to 0. Again, you're either going to have to factor that or use the quadratic equation. It's up to you. Doesn't matter which you do. I like factoring, so I'm going to try and factor. I don't know what that is. Maybe I won't try and factor. Oops, that should be just 1x. But I still don't know how I'm going to make it equal to 2 in the middle. So that means I'm stuck. I didn't like you guys very much, eh? So that means I'm stuck doing the quadratic formula. So that is negative b plus or minus the square root of b squared minus 4 times a times c. Do I have? Yeah, I have the signs right. Okay, and let's see. And all over 2a, so 2 times 3, which is 6. But what I'm noticing here is that when I go to do this, under here, 4 times 3 is 12, 12 times 6 is 72, so I have 4 take away 72. I have a negative underneath the square root. Can't have that, that's an imaginary number, so what does that mean? That means there are no local max or local minimums. There just aren't any. This graph is either always going to be going up or always going to be going down. How do I know? Pick any number you want, put it back into the derivative and see whether it works out to be positive or negative. So I'm going to choose the easiest thing I know, 0. If I put 0 into here, this would be 0 plus 0 plus 6. I get a positive number. So because I get a positive number, that means it is always increasing. All right, so now what about points of inflection? Because just because there's no max or mins does not mean there's no points of inflection. So the second derivative would be 6x plus 2. I can make that equal to 0, 6x plus 2. So negative 2 is equal to 6x. So x is negative 2 over 6, which reduces to negative 1/3. So there is a potential for a point of inflection where x is negative 1/3. So I'm going to check. I'm going to pick a number less than negative 1/3, like negative 1. I'm going to put it into the second derivative, and I'm going to see whether it's positive or negative. So 6 times negative 1 is negative 6, plus 2 is still negative 4, so it's concave down. After negative 1/3, so say 0, this would end up being positive, which means it's concave up. So I do have an inflection point, unfortunately, when x is negative 1/3. So I need the y value for that. So I have to put that back into here. So negative 1/3 cubed is negative 1 over 27 plus negative 1/3 squared would be 1/9, so 1/9 plus 6 times negative 1/3 would actually be negative 2, so minus 2. So again, that ends up being a really disgusting fraction, but it's negative 1.9. Okay, and I just did that with my calculator. So now, if I'm drawing this, I don't have a lot of space to draw it, but if I'm drawing this, I have an inflection point at negative 1/3 and almost negative 2. There's an inflection point. The graph is always increasing, but before this point, it's concave down. And after this point, it's concave up. Ta-da, I just graphed it. All right. The last one I asked you to do was E. Now you could have made that more exaggerated. We don't know how much of, like, we could have made it really go like this and really go, because we don't know. So there is some leeway in there because remember, it is a sketch of a graph. We haven't done a table of values to be super exact or anything. So it is just a sketch. So as long as you have it going in the right direction and concave in the right directions, you're fine. 8e, x to the 6th minus 2x cubed. Ew. All right, so same process, first derivative. That would be 6x to the 5th minus 6x squared. So I can at least take a 6x squared out, which would leave me with x cubed minus 1. And so make that equal to 0. Either 6x squared is equal to 0, which means x squared is equal to 0, sorry, which means x is 0. My brain was already over here. So x cubed minus 1 could equal 0, which means x cubed is equal to 1. Just take the cube root of both sides. If you take the cube root of 1, you get 1. So those are my potential local maximums and local minimums. So 0, 1. So if I pick a number less than 0, like -1, and I put it into here, I end up with -6 minus 6, which is -12, so I end up with a negative. So before 0, this graph is decreasing. Between 0 and 1, so at like 0.5, let's see, 0.5 to the 5th times 6 minus 6, and 0.5 squared is 0.25, so times 0.25, I end up with a negative, which means I am increasing. So I know I've got a local minimum when x is 0. I can figure out the y value because I can put it back into here, which is going to be 0. So I have a local minimum when x is 0, y is 0. Now I have to pick a number after 1, so say 2. 2 to the 5th times 6 minus 2 squared is 4 times 6 is 24. I end up with a positive number. So that is also increasing. I don't know why I put negative there because it was a positive number. I'm sure it was. Let me do 0.5 again. 0.5 to the 5th. Whoops. 0.5 to the 5th times 6 minus 6 times 0.25. Oh, sorry. Let me do this again. Okay, this is positive. It's increasing. Sorry, I was wrong. I put a negative here and I said it was increasing, but it's not. It's decreasing again. So there isn't a local minimum there. The local minimum actually happens at 1. So I was wrong there. It actually happens at 1. So down here, when I picked a number before 0, like -1, I got a negative answer, which meant it's decreasing. When I picked a number between 0 and 1, like 0.25, I still got a negative answer. So it's still decreasing. So there isn't a local maximum or minimum there. When I picked a number bigger than 1, it turned out to be positive, so there's a local minimum there. So when x is 1, that'd be 1 to the 6th minus 2 times 1. So that would be 1 minus 2. So that would be -1. Sorry about that. So I have that, but now I need to figure out points of inflection. There doesn't appear to be a maximum. So inflection, second derivative would be 30 x to the 4th minus 12x. So make that equal to 0, and I personally would can't take out 12, but I could take a 6x out, which would leave me with 5x cubed minus 2. That's disgusting. So 6x could equal 0, which means x could be 0. Or 5x cubed minus 2 could be 0. So 5x cubed could equal 2. So x cubed could be 2 over 5. So I'm going to take the cube root. You have a button for that. I'm going to take the cube root of that. So, there it is. Cube root of 2 over 5. Second. I'm just making sure that I'm being really specific with my calculator. I get 0.736. Okay, I get this horrible number. All right, so I get 0 and 0.74, we'll say. So I need to pick a number before 0, like -1, and I need to put it back into the second derivative. So if I do -1, this is going to be actually 30 plus 12, which is positive, so it's concave up. After 0, and I can't go above 0.74, so I'm going to choose 0.5. If I do 0.5 to the 4th times 30 minus 12 times 0.5 is 6, so minus 6, I get a negative, so it's concave down. So I have a point of inflection when my x is 0. The question is there a second point of inflection here? So I need to pick something after 0.74, so I'm going to pick like 1. So if I do 1, this would be 30 minus 12, which would be positive, and bummer, it actually does switch again. So there's another point of inflection at 0.74, which is gross. All right, I'm going to leave up some of this information. I'm going to leave up my 2 little tables that I made because those are helpful. And I'm going to figure out my points of inflection. So if x is 0, that's 0. And if x is 0.74, which is gross, but 0.74 to the 6th minus 2 times 0.74 cubed, I get negative 0.65. Okay, now those are rounded, that's okay. Bye. So that's fine. So now I have to graph it. So if I'm going to graph this, I know there's a local minimum at 1 and -1. There's a local minimum there. I know there's a point of inflection at 0 and 0. And I know there's another point of inflection at 0.74 and -0.65, which is going to be like, I don't know, right here, which is disgusting. Okay, so all the way to here, it's decreasing because that's a local minimum. After this point, it's increasing. Now, it's concave up from 0.74 onwards, so it's concave up. Between 0 and 0.74, it's concave down. And after and before 0, here, it's concave up. So what happens is it has like this little bump in it, and then it turns again. So it does that, which is bizarre, but that's what it does. All right, so that is 8. Again, the answers aren't at the back of the book, hence the reason why I did them here. So no work to do for Friday. Really, all I wanted was to be able to answer some questions so that hopefully we can start fresh on Monday. Okay? Talk to you again sometime.